Okay, so we're talking about a mound of gravel in this problem. So it's back to the cone that we did at the beginning. A mound of gravel is in the shape of a cone with a height equal to twice the radius. That's what we had before. The volume of the cone in terms of the radius is given by, and there's the function. Find the inverse that will give the radius as a function of the volume. So we don't have to switch anything, we just have to solve for r. So we're going to write v equals 2 pi over 3 r cubed. We're going to multiply by the reciprocal of that constant, which is 3 over 2 pi. And then that's going to give us 3v over 2 pi equals r cubed. Then we're going to take the cubed root of both sides. And so we're going to have r equals the cubed root of 3v over 2 pi. So you may remember we did something like that before. Okay, so we found the inverse, got r by itself. Then use the inverse to calculate the radius of such a mound of gravel measuring 100 cubic feet. Now that's the volume because it's cubic feet. So v is 100. And they tell us to use 3.14 for pi. Okay, so we're going to go r equals the cubed root of 3 times 100 over 2 times 3.14. Now, what I did on my calculator, I put all of this in. You have to use the parentheses though. So I put in like 3 times 100. Actually, I think I put in 300. Divided by, and then you're going to need parentheses, 2 times 3.14, because if you don't do that, it won't come out right. And then I took that whole thing, whatever the answer was, used my answer key, and I raised it to the 1 divided by 3 power. Your calculator might have a cubed root button. Mine does, but I just did it this way for some reason. And I'm getting it to be approximately 3.62844 and some other numbers, but we're going to round that off then to, it's a radius of about 3.63. Okay? So you might have to play around with your calculator a little bit to get that answer, but you could write it with a fraction for the exponent or find your cube root button if you have one.